All right, here we go. This is Algebra 1, Section 7.5, factoring a trinomial where there's just an x squared. It's just 1x squared. So it's not like 2x squared or 3x squared, where the ax squared plus bx plus c, a equals 1. So we're just factoring that specific type of trinomial or specific type of polynomial. When we put a number that's not 1 in here, we'll have to do a little bit more work, but we're just focusing on this case for this video, for this section 7.5. So what I'm going to do is I'm just going to do these 6 examples, run through them. I'm going to use the diamond problem method as kind of a structure to get there. So let's just jump right in. So when we're told to factor something like x squared plus 11x plus 10, what we're trying to do is we're trying to find the multiplication problem that gives us this as the answer. So I know when I multiply these two things, right, if I'm going to multiply this, I'm going to go x times x to get this x squared. I also know I got to multiply two things to give me 10, and that whatever numbers go here and here, I'm going to get that x, and these two numbers are going to add together to give me 11. So what we can do is we can, instead of like drawing up the box and doing all that, we can do a quick diamond problem. So the diamond problem says, take this number here, the number that's all by itself, the 10, put it in the top of the diamond, take the 11 in front of the x, put it in the bottom of the diamond, and now what we're doing is we got this diamond problem with the 10 and 11, and we got to find these side numbers. And for any diamond problem, these two side numbers add together to give you the bottom one, and they multiply to give you the top one. So I'm going to say, okay, what two numbers multiply to 10? Like 5 and 2 multiply to 10, but those add to 7. They don't add to 11. So like rats, those don't work. Well, what else multiplies to 10? Well, 10 times 1 multiplies to 10, and that adds to 11. Right? See, 10 times 1 is 10, 10 plus 1 is 11. So these two side numbers multiply to the top one, add to the bottom one. And that's what we're doing in this area model diagram that's on the other video. So here, what I do now is whatever these answers are, those go in here. X plus 10 times x plus 1. That's our factored answer. Boom. Got it. All right, let's go on to the next problem. So what I'm going to do is I'm going to erase the work. You can always rewind the video and look back at the example. And we're just going to crank through some of these examples here. So on number 2, we have x squared plus 3x minus 28. We're told to factor it, which means write the multiplication problem. So I'm going to go to my diamond problem. Right. Okay. I need two numbers that multiply to negative 28 and add to 3. So numbers that multiply to give me a negative. Well, let me just take this negative 28, and what I'm going to do is I'm going to divide it by something and see what we get. These two numbers, negative 28 divided by something equals something, put them there, see if they add to 3. So like negative 28 divided by 2, that's negative 14. So 2, negative 14, you know, that would add to negative 11. That's not what we want. Rats. Let's try 4. Negative 28 divided by 4, that gives me negative 7. Put them in the diamond problem. Those two add to a negative 3, not a positive 3. So like, okay, well, what if I try this? If I divide it by a negative 4, right, that gives me positive 7. If I add those two, I get a positive 3. So I can now say x minus 4 times x plus 7 equals x squared plus 3x minus 28. And you can always draw out the box and multiply these and see that you get that. So basically, another way you could have gone about this is say, all right, what two numbers multiply to negative 28? Or just multiply to 28. 4 and 7 multiply to 28. If I want to make it a negative 28, I got to make one of them negative. And I know these two numbers need to add to a positive 3. So the bigger number's got to be my positive number. All right, and the more practice you get with these, the better you'll get at doing them. All right, let's move on to the next problem. So number 3, here we have x squared minus 8x plus 12, blank times blank. So we're factoring this. And whenever we have just a regular x squared, and notice this method that we're doing right now only works when it's a regular x squared here. If I have a number in front of the x squared, I have to do a little bit more work. I can still use the diamond problem, but that doesn't give me the answer if it's not just a regular x squared. These ones, it's just a regular x squared, we can just use the diamond problem. All right, so what I do, first step, I take this 12, put it in the top of the diamond problem, take the negative 8, put it in the bottom of the diamond problem. I need to find two numbers that multiply to 12, add to negative 8. So I think in my brain, I mean, you can write this out if you want to, but I think, all right, what multiplies to 12? 12 and 1. Those add to 13. If I make them both negative, right, negative 12 times negative 1, that's negative 13, but I need negative 8. So think again. 3 times 4, that's 7. 2 times 6, 2 plus 6 is 8. I want negative 8 though, right? So I got to make them both negative. Negative 2 times negative 6, and negative times negative does give me a positive. So it multiplies to that positive 12. But if I add two negative numbers, the sum, the answer to the addition, is more negative. Negative 2 plus negative 6 is negative 8. So here I get x minus 6 times x minus 2. And it's okay if you write it x minus 2 times x minus 6. If you swap those, that's okay. The same thing is like negative 2 times negative 6 is 12. Negative 6 times negative 2. It's still 12, right? It is commutative. That's the math word we use for that. The order doesn't necessarily matter. All right, let's look at problem 4 here. We've got x squared plus 10x plus 25. Go ahead and pause the video and just try this one. Factor that. What multiplication problem do we get out of this? And notice, sorry, I don't know if I've been saying this enough, but all of these problems, the instructions are to factor. So go ahead and pause the video, try that problem, and then I'll go over it. All right, so we're going to our diamond problem. Okay, these are our numbers. The 25, the number, the constant that doesn't have an x, that goes in the top. The coefficient on the regular x, that goes on the bottom. I need two numbers that multiply to 25, add to 10. What multiplies to 25? 25 and 1, 5 and 5. Guess what? 5 plus 5 is 10. So here we have x plus 5 times x plus 5, which is the same as x plus 5 squared. We could write it either as x plus 5 times x plus 5 or as x plus 5 squared because we have the same binomial, that same thing, x plus 5 multiplied by itself. Cool. Let's go to the next one. Number 5. Here I've got x squared minus 12x plus 36. Go ahead and try this one. Pause the video. When you finish, turn it back on and check your work. So once again, looking at the numbers, I'm going to jump to the diamond problem. The 36 is going to go up here. The negative 12 is going to go down here. Right? The number in front of the x, regular x goes here. The 36, the regular number, no x, goes to the top. That's only when it's just a 1x squared. So we think, all right, what numbers multiply to 36? Always start with the multiplication part. Well, like 36 and 1, 12 and 3, 9 and 4, 6 and 6. Which of those add to 12? Well, 6 plus 6 adds to positive 12. We want it to add to a negative 12. So whenever we have a positive that they multiply to and a negative that they add to, what we have to do is we got to make them both negatives. Right? Negative 6 plus negative 6 is more negative, negative 12. And if we multiply two negatives, it gives us a positive. So here we get x minus 6 times x minus 6, which, because these are the same, we can write this as x minus 6 squared. All right, last problem here. There's a little bit of a tricky one here. We have x squared minus 49. Tricky. Go ahead and try this though. Pause the video, give it a shot, and think about it for a moment. Even if you don't get it, just give it a moment to think about how to do it. All right, so looking at this, we're like, all right, this is different from these ones because it doesn't have that regular x term. It doesn't have the linear term. We call it a linear term because it's just like x to the 1. That would make, without this, like negative 12x plus 36 would be a line if we graphed it. All right, so that this term is our linear term. It's missing that linear term. It just has the squared term and the constant term. So we could rewrite it, if we want to, as x squared plus 0x minus 49. And sometimes just putting that 0x in there is helpful. So what I need to do now is I need to find two numbers that multiply to negative 49 and add to 0. So here, to add to 0, these two numbers need to be opposite numbers. In other words, it's got to be the same number, one positive, one negative. Well, what number multiplies by itself to give us just regular 49? Well, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49. So if I make one of the 7s positive and one of the 7s negative, a positive times a negative gives me a negative. A positive times a negative, a positive plus a negative, 7 minus 7, 7 plus negative 7, that's 0. So here I get x plus 7 times x minus 7, and you'll remember, maybe, right, we call these conjugate pairs. Anytime that we multiply conjugate pairs, like x plus number times x minus same number, that middle term, that linear term, cancels out, it's 0. So this, right, verifies what we learned in section 7.2, 7.3 about multiplying conjugate pairs. That middle term is 0. So anytime we have a middle term of 0, we know we're going to get conjugate pairs as our answers for factoring. In other words, you can say two numbers that multiply to this, that add to 0, these two have to be opposites. In other words, positive, negative, same number. All right. Hopefully this is enough to kind of get you through the 7.5 homework. I know there's a couple of 7.5 homework problems. Remember, I have office hours. You can email me with questions. Have a wonderful day, and I hope you enjoyed the video. Go Bulldogs!